So we've talked about all sorts of different types of geology and different types of geologists, but what do they do? Like, what does the day in the life of a geologist look like? Well, for one, it depends a lot on that particular geologist. But more than anything, geologists are just scientists. And so geologists use empirical data and observations to try to better understand the world around us. So this view is Monument Valley on the Navajo Nation. This is kind of one of the most famous views. On the left, these are the mittens, and because they kind of look like mitten hands. And it's Merrick Butte over on the right there. So we're going to use this as an example. Right, so a geologist is just trying to answer questions. So if we go to like the most basic sort of field geologist job here, the first thing they're going to do is be like, what is this? Right? What's here? And if you get up close and personal with the rocks that are here, what you're going to find is that at least the monuments themselves, where it's really steep, are made out of a rock that looks a lot like this on the screen. And so it's got little sand-sized pieces of rocks in there. It's got these kind of like crisscrossing sort of layers. So our geologist is going to take that and say, okay, these are made out of a rock called a sandstone, right? And then they're going to ask kind of when were these rocks formed? That's in geology. We ask a lot about when, and the answers are often really old. So there are ways to do this, and that's actually one of the upcoming lessons. But what we know about this is the steep stuff is the Deshay sandstone, and we know that was formed somewhere around 250 to 300 million years ago. And so that's what we call the Permian, and that is even before dinosaurs. Where? That's the other kind of big question, right? Where do you find these rocks? Where does that same type of sandstone occur? Well, this is what's called a geologic map, and that's how we show the spatial distribution of different rock types, and that's a lesson coming up too. You'll be using these a lot. And so you can see that anywhere you have these green blobs, those are actually outcrops of that Deshay sandstone. So now we know where all it was. And based on some of our geology rules that you're going to learn about, we know that since they're all the same rock, those all used to be connected at one point. They used to be one big layer of sandstone. So how did these form? How did we get to this? How did we get sandstone? How did that sandstone disappear and only leave behind these little blobs of rocks? Well, those sandstones came from sand dunes. During the Permian, Arizona, specifically northern Arizona, was actually a vast sand desert. So probably really similar to like the Sahara is now. So we find that sandstone over a pretty big swath of the Southwest. So we know there were big sweeping sand dunes, and that comes back from those cross beds, those layers you could see in that rock earlier. Now, if you take a good close look at those rocks, you might get lucky and find some footprints. And I know that the Deshay sandstone does have some reptile footprints, and these are some examples of ones that actually probably lived in the area. They're what are called mammal-like reptiles. I always think though that these big two, they got their heads switched. But you can see like footprints on the sand dunes. And based off what we know from the Atacama Desert, which is the driest place on Earth, there is life there. And sometimes you actually can preserve their little footprints, even with a lack of rain, mainly from the fog that blows off of the ocean. So it's enough just to get the very top of the sand wet and preserve those footprints, which is what probably happened here. all those sand dunes and footprints get buried in deeper and deeper in sand. That gets buried under more and more stuff. Right on top of that is the Shinarump conglomerate. And that is mostly deposited in river environments. And so you can see that it got a lot wetter. It was all buried nice and deep, turned to stone through a process called lithification. And then a few million years ago, the entire area of the Four Corners region of the U.S. was uplifted by about a mile. And when that happened, all the rivers and the streams in the area started eroding down really, really fast. In some areas, that ended up leaving big canyons like the Grand Canyon or Canyonlands. In other places, like in Monument Valley, it's actually eroded quite a bit more. So this is just a further progression of that erosion. So you can see just what's left. So it's a dynamic, changing environment, and geologists, that's as a first step that we can look at that, and it gives you a peek into a world 250 million years ago, which is pretty amazing.